Assalamualaikum warahmatullahi wabarakatuh. Today I'm going to present about statement and logical connective. So our group members are Nitnur Emilia Patricia binti Muhammad Jaluddin. The metric numbers are 2021466518. The second one is Nur Anisa Lilah binti Marzuki. The metric numbers are 2021863678. So before we start, I'm going to introduce to you about a logical connective. A logical connective is a word that usually written as a symbol that carries a particular instruction or logic on how to operate a statement or compound statement. Logical connective can also be used to join or combine two or more statements to form a new statement. So the description of the concept. Statements are declarative sentences that can be either true or false. In mathematical logic, statements form from the basis logical reasoning and the construction of mathematical proof. They allow to persist the formulation of mathematical ideas. So, the first logical connective is conjunction. The symbols are like arrow, up arrow. So, the statement is implies for statement N. This next one is disjunction, which is symbols like V. The statements are or. The next one is negation. We use negation for not statement. So the symbol is like the wavy one or the upside down, like that. L upside down. So the next one is conditional or implication. Or it's a right arrow for if then statement. The last one is biconditional for if and only if. The symbol are like arrow from left to right. So the logical connective and its definition. For not P, if the is for the negation of statement P. P and Q. If P is true and Q is true, then P and Q is true. Otherwise, P and Q is false. P or not Q. If P is true or Q is true or both P and Q are true, then P or Q is true. Otherwise, P or Q is false. This one is P implies Q. If P is true, then Q is false. Then P implies Q is false. Otherwise, P implies Q is true. Last one is P biconditional Q. If P and Q give the same true value, then P biconditional is true. Otherwise, P biconditional Q is false. So, in the preview activities for this section, we'll learn about compound statement and their truth values. This information can be summarized with their true values table. In MATLOGY, a truth table is a chart of rows and columns showing the true value, either T for true or F for false, of every possible combination for the given statement as operated by logic and connective. So we're gonna give an example question to solve. So we give a true statement which is S, the sky is cloudy. T, it will rain soon. U, I need to bring an umbrella. A, if the sky is cloudy, then it will rain soon. B, it will rain soon and I need to bring an umbrella. C, I need to bring an umbrella if and only if the sky is cloudy. D, the sky is not cloudy and it will not rain soon. E, the sky is cloudy or I need to bring an umbrella.
The next one is solving the question. We have to write the following propositions in symbols. If the sky is cloudy, then it will rain soon. And the symbol is S implies T. For B, it will rain soon and I need to bring an umbrella. The symbol is T and U. The next one, C. I need to bring an umbrella if and only if the sky is cloudy. And the symbol is U biconditional S. For D, the sky is not cloudy and it will not rain soon. And the symbol is not S and not T. For E, the sky is cloudy or I need to bring an umbrella. The symbols is S or U. For A, let's start with the propositions S implies T, which states if the sky is cloudy, then it will rain soon. Firstly, we create the table with columns for S, T, and S implies T. We enumerate all possible combinations of truth value for S and T, and next we can determine the truth value for S implies T based on the logical implication. So, if S true, then and T is true, then the statement is true. If S is true, then T is false, then the statement is false. If S is false, then T is true, the statement is true. If S is false, then true. If S is false and T okay, if else is true, then T is true, the statement is true. If else is true, then F and T is false, then the statement is false. If else, if S is false and T, then T is true, the statement is true. If S is false, then T is false, the statement is true. And the next one is B, T and U, which states for it will rain soon and I need to bring an umbrella. If T is true and U is true, then the statement is true. If T is true and U is false, then the statement is false. If T is false and U is true, then the statement is false. If T is false and U is false, then the statement is false. Yes. We have U representing I need to bring an umbrella and S representing the sky is cloudy. The column U by conditional S represents the logical biconditional meaning if and only if U and S are both true or both false. So let's look at each row. And if U is true and S is true, and the statement for U by conditional S is true. And if U is true and S is false, then U by conditional S is false. And if U is false and S is true, then U by conditional S is false. And if U is false and S is false, then U by conditional S is true. And for the next one, D, not S and not T. We have not S representing the sky is not cloudy and not T representing it will not rain soon. If S is true and T is true, then the statement is false. If else is true and T is false, then the statement is false. If S is false and T is true, the statement is false. And if S is false and T is false, then the statement is true. And for the last one, E, we have S or U. We have S representing the sky is cloudy and U representing I need to bring an umbrella. So if S is true and U is true, then the statement for S or U is true. And if S is true and U is false, then the statement is true. And if S is false and U is true, then the statement is true. And the last one, if S is false and U is false, then the statement is false. And for the summary, the application of logic is important in real life because it is used every day. It helps us come up with logical reasoning and a good solution to a problem or an argument. And that's all from us. Thank you.